Dina's going to be going over an example for us, so let's get straight to it and get those questions in. Take it away, Dina.
Thank you. We're looking at the even numbers as an example of how to work with linear patterns. So let's look at how to create the general term of the even numbers. What would all even numbers look like? On the board I've got the 2, 4, 6, 8 sequence with the general term, and anyone that asks you for a general term, any generalization that gets done in mathematics, all you are saying is you're creating a formulae that would work for all cases. That's what's called as a general term. And so all cases in any sequence would be the Tn sequence. So we're looking for the nth term, and that's what we call it, the nth term of a sequence. So that would be my nth term. Okay, and the sequence is called linear because I am going to add, let's look at that, I'm going to add 2 to 2 to get 4, I'm going to add 2 to 4 to get 6, I'm going to add 2 to 6 to get 8, and so my pattern is the same. There's a constant 2 that's being added all the time. Now, before we jump into what this nth term is for the evens, I want to look at, let's go on to another page and just write that again. But I'm going to split them up a little bit just so I can show you 6, etc. We only need the first 3. Okay, where the first one, because it's linear, any linear expression will always have a coefficient plus a constant. So my nth term will be a coefficient of n plus b, where n is to the power of 1. And that's why it's called linear, because remember from grade 9 where you did the straight line, your straight line equation was y equals mx plus c, where x was to the power of 1. And so an expression that involves a power of 1 will be drawn graphically as a straight line, and that's where the linear equation comes from. So this one is a similar equation where there's a coefficient, there's n that stands for the n in the term, and then there's a constant b. So that will be the general term for everyone. So if this is T1, and this is T2, and this is T3, then this term 1 over here, if we take that general term as an plus 1, then T1 will look as follows. N, the first term, is equal to a, n, standing for 1, plus b. And so your T1 will simply be a plus b. If we look at T2, and we now look at that T2 there, T2 is a, remember n stands for the term that I'm looking at, n is 2 and plus b. So now I get T2 as 2a plus b. In other words, I have formulated a general T1, a general T2. In all cases, my T1 will always be a plus b, and T2 will always be 2a plus b. So if I had to take the difference between T2, T1, I know that for my example it's 2, but let's see what that 2 would equal to in terms of the general term. It would be 2a, it would be 2a plus b, and then I'm going to take away what T1 is, so I'm going to take away a, and I'm going to take away b. So I'm left with 2a minus a is a, and b minus b is 0. So this T2 minus T1 is just equal to a. So if we carry on, we have our a value is always going to be the difference between T2 and T1. So remember when we said the general term, Tn equals a n plus b, we now are saying that to get your coefficient of that general term, all you need to go and do is take the difference between T2 and T1. which in the even numbers, the difference between 2 and 4 is just 2. So therefore, for even numbers, my Tn is going to equal 2n plus b. So I'm getting rid of the a, I'm getting rid of the b. What will the value of that constant be equal to? Well, that's easy. We're going to take the first term. Remember, it was 2, 4, 6, etc. Tn's value for T1 is 2. So that's equal to 2 times 1 plus b. So my b, if I solve the equation, would be 2 minus 2 is 0. So my b is 0. So my even numbers then are going to be Tn, all even numbers, are of this form, 2n. So any description of even numbers would have a description, an algebraic description of 2n, and so that pattern can be represented algebraically as 2n. If the even numbers have a pattern, what do you think the odd numbers would look like? What would they be expressed as if I wanted to get the next even number, or the next odd number? Well, how far apart is an odd from an even? 1 or negative 1. It's on either side of that even number. So if I had to add or let's go on there. Actually, can go on there. Can I go down?
Yeah, I think you can. Just give it a bit of a push down. Maybe it's best to start in
there we
the
go.
extend
There we
page. There you go.
There you go. Okay. Oh, wonderful. I found a little trick. Right, my odd numbers, since they are on either side of 2n, could be represented as my general term, either 2n plus 1, 1 more than the even, or 2n minus 1 on the left side of the even number. And if we were to look at what the general term would be, let's look at a sequence of odds. And let's look at the odds starting off from 3, 5, 7, etc. We learned that to get Tn, the a value is always T2 minus T1, which in this case, it's again 5 minus 3 is 2. So our general term Tn is going to be an plus b. And a number of you are going to be asking, is it always an plus b? Yes, because the linear always has a coefficient and a constant. Coefficient is a and the constant is b. So yes, it's always going to be that. And for our odd numbers, it's going to be 2n plus b. How do we find b? We take and we substitute in that first value, that first term. Tn is any term. So T stands for the term in the pattern. Okay, so if I'm creating a pattern and you are going to give me a series of numbers, then for me to tell you where I am in that sequence, I'm going to call out or identify that specific term. So T is that thing that identifies the term in the pattern. And when I say N stands for any. Now, it could be N, it could be K, it could be A, it doesn't really matter, but mathematicians have conventionally given it the N as the nth term. So is any term, and we also refer to it as the nth term. So if I say to you T1, okay, let's just do that nicely, T1, then what exactly are you referring to? It's like calling a person by name. We are calling that term by name. So T1 refers to the first term because there's a 1 as a subscript. Okay? T2 is calling the second term by name. 2 referring to that second term in that pattern. So it's a unique position. Whereas Tn refers to anyone. You don't know which one you're going to refer to or going to call, so you say the nth term. Okay? So T3 refers to which term in the sequence? The third one. So you know exactly where to go. You're not going to the first or the second, you're going to the third one. Does that make it clearer, Indy?
Yes, I'm sure it does.
Good.
Thank you, Dina.
Okay. So Tn is the name of the terms or the labels that we give the term. And the A n plus b refers to the expression, there's an algebraic expression that you're going to be able to derive for every single pattern that is linear. And I just need to get the computer to listen to me. Equals A n plus b. So that would be a linear pattern. What do I mean by linear? It means that A is going to represent a coefficient, and B is going to be a constant, and n is to the power of 1. So remember the nth term, n stands for the name of the term. So if n is 1, the first term. If n is 2, the second term. If n is 3, the third term. So n represents any term in the sequence. But when n is being multiplied by something, it's not always multiplied by 1. It could be multiplied by 2 or 3 or negative 2 or negative 3. So this value over here is just a value that n is multiplied by. So it stands for the coefficient of n. So whenever you find a linear sequence, you're not just going to have n there. You're going to have something multiplied by n. And that something we represent by A. And then the B we represent as a constant. So it will be a constant term. So a linear function, the maximum that this linear function can be is always to have firstly a coefficient and secondly a constant. It sometimes might have a b as 0, but this is the greatest expression that a linear can have. Now, I'd like to show you what a quadratic looks like so you can see the difference. Let's just extend this page. So let's just go down here. So if we were looking at a quadratic pattern, then we would have Tn equals an squared plus bn plus c. So anything that's quadratic, in other words, to the power of 2, will have the highest power is 2, but then it will have a term with an n, and then it will have a constant. And you'll certainly deal with these next year. If it was cubic, then the highest power would be 3, then you'd have a square and a linear and a constant. So it's the greatest way that an expression can be expressed if it is linear. Okay, so it's a convention, it's a mathematical convention. So you wanted to know what A was, and you wanted to know what B was. A is the coefficient of n, and B is a constant term. How we get those, we will have to look at another example. Shall we look at another example?
Yes, let us. Yes.
So let's...
What we could even do, we also want to give the learners a bit of a test during the break. So if you've got one of those,
okay, we can do that.
We've got a break in about 5 minutes' time. So guys, I hope you guys are all feeling sharp and ready for a challenge.
Okay. All right, so if you are asked to find the nth term, you'd always start with, it looks like this. That's what it looks like. Your job is to go and find what A is and find out what B is, okay, in this whole process of finding that linear pattern. And if we look at the pattern 5, 8, 11, etc., then we can see that we're going up in threes. But if you wanted to find out what is a term down here, let's say the 50th term, okay, what would the 50th term look like? Are you going to sit 11 plus 3 plus 3 plus 3 until you get to 50? Well, that would be pretty boring, and that's not what mathematicians do. Mathematicians want to find the quickest route to find the 50th term. So we'd like to say, if I had a formula of finding all these terms, then I would just have to plug into the formula, and voila, we'd have the 50th term out. So we don't really want to sit there and plus 3 for all these terms and then find the 50th. You can by all means do that, but you're actually giving yourself a little bit of punishment. So let's find the most elegant way of actually determining what that formula is without adding threes. And the A that we found is always going to equal to the T2 minus T1, just recapping from earlier, and that in this case is 8 minus 5 is equal to 3. So again, I repeat, will A always be T2 minus T1? If it's linear, in other words, if you're adding the same thing over and over again, then yes, A will always be 3. So Tn will now at this stage be 3n plus B. So our job is to find A and to find B as well. How are we going to find B? By simply saying that if Tn represents any term, then T1 must represent the first term, 1 describing the first position in your pattern. So that would be 3 times 1 plus B, and that's equal to 5 in this case. So our B would be equal to 5 minus 3, which would equal 2. So we now say that for this unique pattern over here, that our Tn is 3n plus 2. Okay. And now, without doing any other calculations, what would T50 equal to? In other words, the 50th term in this pattern, what would it equal to? That would equal to 3 times 50 plus 2. So we've got 150 plus 2 is 152. Look how elegant that is, that without going and adding and adding and adding until you get to the 50th, we've actually established what the formula is for any term, and we've been able to say, using that formula, just quickly we can plug in any value that you'd like. So if we wanted to know what the 1000th term would be, we wouldn't have to sit and add 3's for 1,000 times. We could just say 1,000 times 3, 3,000 plus 2, 3,002 is the value of the term. Okay, so let's give you a little bit of a challenge. Let's go up here and say Tn is equal to 301. And let's give you the sequence of, okay, let's just do this. Let's erase that. If Tn is equal to, and we've also got that the sequence is, let's make it 4, 7, 10. Okay. Now I know that you've picked up a little bit around how to get the nth term. My hint to you is to find out what Tn is first, and in the general term, and then I'm going to leave you to play a little bit. Tell me what you think the term is. What is n? What n gives you a term of 301? Okay, so if Tn is 301 and the sequence is 4, 7, 10, what is n that gives us 301? And over to Indy so she can take us through that.
Fantastic,
Challenge.
guys. Yeah, so what we're going to do is we're going to take a quick break. I'm one finger click away from actually posting the question. So that's what I'm going to do. Guys, have a little think. You've got about 2 minutes, and we'll see what the answer are when we get back. So, see you after the break. Welcome welcome back, Mindsetters, and I hope that you're having a fantastic session. I see that lots of you are actually writing in and letting us know answers to the question. We're still waiting. Guys, let us know if you have the answer. Dina, they're taking a bit of time. I'm just hoping that Facebook's being slow. That's what I'm hoping. We do have a question in the meantime that we can go over. Okay.
Let's have a look at that.
So this one is from Megan, and Megan wants to know, can B also be negative?
Well, Megan, you're on your way to being a mathematician, because that's the kind of questions that mathematicians ask. What if B is negative? Or can B equal be a negative? Did you think about A? Could A be negative? Okay, so if you really have understood a concept, you can really take that test of asking those fantastic questions. Can B be a negative? And the problem with mathematics often in class is that your teacher will do a beautiful example where everything is positive and everything works out nicely. All of a sudden you get given the homework, you arrive home, and all of a sudden it doesn't work like the teacher showed you in class, right? And you then need to be that mathematician in action and say, well, let me work through this and see what other permutations I can get out of this. And certainly let's have a look what other values B could come out as. And let's also, Megan, and for everybody else, see what A could also equal. So let's look at the sequence of -5. Let me pose one. -5, -7, and -9. Okay? And let's see what would Tn come out as. Okay? Well, firstly, let's look at what's happening between -5 and -7. So let's look at T2 minus T1. What do we get? We get a -7 minus a -5. So we get, in the end, a -2. And what's happening between T3 and T2 is the same. We've got -9 minus -7 is also -2. So before you jump in, and this is a good rule, just have a look, are we adding the same thing? So are we expecting it to be linear, or is the sequence doing something completely crazy? Okay, so we've established we were adding -2 to -5, and we were adding -2 to -7, so certainly it is linear. You only need to be given a minimum of 3 terms to establish that. So now, if T2 minus T1 is -2, what does that tell us? That if Tn is always An, so if Tn is always An plus B, that we now have a Tn of -2n plus B. So we start off with a formula with a plus B. You can use a minus B if you like. It doesn't really matter. It's irrelevant. But in the end, the B value that you get, let's go and investigate that, what it could be. So we're sitting now with a coefficient of negative. So remember the evens and the odds, they had the coefficient of 2. All of a sudden, A comes out negative. So yes, A can be a negative value. And then, are there any constraints on B? Well, how do we get to B? We take the first term, which in this case is -5. That's T1 is -2. Remember, n stands for the number in the sequence, so it's 1. And plus B, and this is now equal to -5. Okay, let's solve for B. We get a -2 over here, so the B is -5 plus 2, so B comes out as -3. So there we go. B can also be negative. So this Tn for this sequence is -2n minus 3. So that's our general pattern. Remember, n will always be to the power of 1. The coefficient in this case is negative. The constant in this case is negative. And in fact, some of you might be thinking, where am I getting these numbers from? Where are they coming from? I'm not making them up. I'm actually starting with -2 and -3. So I created my own coefficient and my own constant. And because you asked me if B was negative, I created a -3 to give me that sequence. And then we've worked backwards. So if you wanted to practice this on your own, it's a fantastic section because you can start off with the linear, work out what your terms is, and then try and work back to see if you actually get that general term. And you'll see how fulfilling that is if you can go from one to the other. But Megan, that's an excellent question, and my girl, you're on your way to being a great mathematician. Keep it up.